Islands and science have a long history together. From the times of Charles Darwin, when he went to an island to discover how evolution works.
We are interested in understanding how the brain generates behavior and cognition in the real world. But typical studies of the brain are done in the lab.
Basically, you lose how the real thing happens.
It was a dream for many years to study how animals can navigate outdoors while we record their brain activity. We study bats, and bats, they are flying mammals, so their brain is very similar to ours, but on the other hand, they fly fast, so they cover large spaces, which makes it easy to study how large spaces are represented in the brain. In the past, we've built 200-meter-long tunnel and a complex maze here at the Weizmann Institute, but in the real world, animals navigate outside. They have the celestial cues such as the moon, stars, and the sun. Problem is that if I release bats, how do we recapture them? Secondly, bats fly from the cave to the favorite fruit tree and back, and they fly once per night, which is not enough for the statistics. In 2018, it hit me that this is a solution, an island.
And for 2 years, if not more, I don't remember, but now I was looking for islands.
This particular island I found on Google Earth. I was literally browsing around Africa. Suddenly I see this speck of a land that I've never seen before. I clicked the coordinates, looked it up on the internet and said, wow, this is really perfect for what I need. The preparations are very extensive. We're going to live for 1 month on the island, so we bought a whole lot of camping equipment.
We had 2 satellite modems for the internet. We had a fridge for bats and for human food, medications. We brought electrophysiology equipment. We packed the whole lab into 7 big boxes, and then we carry them half the world to an island.
We need to develop a wireless neural logger. We added to it also a GPS to locate the bat and also an altimeter. Selected 6 bats for this research, and then we sailed to the island.
It was amazing to see nature in so much power.
I was sleeping on the beach, got myself a hammock.
It was just the purest nature I've ever seen.
Be working all night, start at about midnight, work until 6 a.m., then crash to sleep a little bit.
The first time I had to actually release the bat from my hands, we didn't know if it was gonna be there, behave as we thought it might, or just fly away and we never see it again. And I think that was the moment I was the most scared.
You just need the bat to fly and to change his head direction, but it doesn't matter where he does it. It's amazing that we succeeded. It was a really hard project.
We found 3 main findings. One is that head direction cells existed outdoors on the island. The second finding, no matter where the bat flew, the neurons showed the same direction. And the third main finding related to celestial cues. We found that the neurons showed the same direction, even though these celestial cues are unstable. The moon rises, moves, and sets. Still, the neurons were rock solid and showed the same direction.
The understanding of how neuronal networks work so that you will know where you are is very critical and can be used for many applications.
These navigation-related areas and memory-related areas that we study are the first to be affected in the Alzheimer's disease. So in principle, it will be very important to understand their normal function in order to understand dysfunction. The broader implication is that it shows that you can and should study the brain in the real world.
This is the new era of science.